We will do this IGCSE paper 21, paper 2 of May-June 24, variant 1. Let's start with the first MCQ. The first MCQ is a gas is heated, the pressure is kept constant. Okay, so a gas is heated, but the pressure is kept constant. Which statement describes the behavior of particles in the gas? What happens to the gas particles? As we heat the gas particles, they start moving faster because the gas particles gain kinetic energy. Okay, so when the particles gain kinetic energy, they start moving faster. So it means the particles move faster. So the MCQ must be from the correct one must be from A or B. Then the particles come closer together or they become further apart. As it's a gas and we are heating it, so the particles are moving faster. And when the particles move faster, they collide with each other. And because of the collision, they start moving far from each other because as they collide, they go far. So option B is correct. Next question. A mixture of ice and water is left to stand and the ice melts. Which row describes what happens to the as the ice is melting? So here, the ice is melting. It means that the solid is changing into liquid. It's melting. So the solid particles are really close to each other. They are tightly packed. And once they turn into liquid, they will move around randomly, sliding over each other, but still touching. They will get a loose arrangement. So when solid changes into liquid, the temperature of the mixture increases. Yeah, the temperature of the mixture increases. And the energy change, kinetic energy. Okay, so the particles gain energy, energy increases. But as the phase is changing, when it is a solid and we are heating it, so the temperature is increasing. But when the solid is changing into liquid, here we have a phase change and the solid is changing into liquid. This process is called melting. So whenever there is a phase change, during a phase change, the temperature remains same. Temperature is not changing. For example, when we are boiling the water, so we have a water in a pan at 25 degrees Celsius, which is a normal room temperature. We're boiling the water, the temperature is increasing. It is gaining energy. The temperature of the mixture is increasing, but a time comes when the temperature becomes constant at 100 degrees Celsius. When the temperature remains constant, that means that when the liquid is changing into gas, when the liquid particles start evaporating and start turning into liquid. And during that time, during the whole boiling process, the temperature remains constant. It remains the same. So when the ice is melting, the temperature also stays the same. And as they're increasing the temperature, so the average kinetic energy of the particles decreases, or energy is used to overcome attractive forces. This one is correct because temperature stays the same because the energy is used to overcome the attractive forces. This one. Okay, because the particles absorb the energy, and when the temperature becomes same, that time energy is used up to overcome the attractive forces and turn into liquid. Next question. Question number 3. Hydrogen chloride gas, which is HCl, it has molecular mass 36.5, is released at P in the apparatus shown. The universal indicator paper turns red after 38 seconds. So it turns 8 after 38 seconds. Okay, because HCl, hydrogen chloride gas, is acidic. So it turns the universal indicator paper red at after 38 seconds. The experiment is repeated using sulfur dioxide gas whose MR is 64. Sulfur dioxide gas is also acidic because this is made up of sulfur. Sulfur is a non-metal, so the non-metal oxides are always acidic. Sulfur dioxide is an acidic gas and its molecular mass is 64. The molecular mass of HCl is 36.5. So from 36.5 to 64 is almost twice as heavier, twice more than HCl. So it's twice times heavier, 2 times almost heavier. So universal indicator paper will turn red for sure, obviously, because it's an acidic gas. And does it move slower or faster? It will move slower because it is heavier. Sulfur dioxide is heavier than hydrogen chloride particles. So hydrogen chloride particles, if they are turning the litmus red, the universal indicator paper red at 38 seconds. So sulfur dioxide will turn it in more time. It will take more time because the particles will move slower as they are heavier. Heavy things move slowly. So it will take 51 seconds. So D is the answer. It will take more time. Next question. 4 statements about atoms are listed. The center of an atom is positively charged. The protons and electrons are located in the nucleus. Protons and electrons have the same mass. Most of the mass of an atom is in the nucleus. Which statements are correct? Okay, so about the atom, the center of an atom is positively charged. This one is correct because the center of the atom has nucleus in it. Okay, and nucleus is whole. Positive charge is present on the nucleus because of the protons. Protons are positive, neutrons are negative. So because of the proton, the whole nucleus is positively charged. This one is correct. Then protons and electrons are located in the nucleus? No, because protons and neutrons are located inside the nucleus. This is wrong. Protons and electrons have the same mass? No, they also does not have the same mass. They do not have the same mass because protons and neutrons have the same mass, which is equal to 1 atm. And electrons are very, very light in weight. They're very small with tiny particles. Then number 4, most of the mass of an atom is in the nucleus. That's correct. So the answer is A and 1 and 4. Next, number 5. The electronic configuration of 2 elements are given. Element L, element M. Element L 2881. This is its configuration. It means it has 1 electron in the outer shell and it has total 4 shells are occupied. 4 electronic shells. For element M, 284. So 284 means it has 4 electrons in the outer shell and there are 3 total shells. The number of shells occupied per occupied shells, they tell the period number. So for the element L, it has 1 electron in the outer shell. It means it's group number 1. Outer shell electrons tell us the valence electrons tell the group number. And the number of occupied shells tells us the period number. So in element L, there are 4 shells. So it means they are in period number 4. It's in period 4. Then as for the element M, it has 4 electrons in the outer shell, in the valence shell. 4 means its group number is 4. It will be in group number 4. And because it has 3 shells, 3 occupied shells, so it tells us the period number, which is 3. So A is the correct answer. Okay. Next, we have question number 6. Which statement explains why isotopes of the same element have the same chemical properties? It's really easy. As we all know that the chemical properties depends on the number of electrons. Depends on the number of valence electrons. Valence electrons or the outer shell electrons. So the number of outer shell electrons are responsible for chemical properties. So the isotopes, what are the isotopes? Isotopes are the elements having same atomic number but different mass number. Okay. So same atomic number, but different mass number. This means, this also says that they have same proton and electron number, but different neutron numbers. Okay, so this is the definition of an isotope, that they have same proton number, but same proton and electron number, but they have different neutron number. So as they have same electron number, so it means their chemical properties will also be the same. Same electron number, same electrons will be there in their valence electrons, so same chemical properties. So they have same electronic configuration. This is the correct answer. Okay, then we have question number 7. Which statements about potassium chloride are correct? Okay, about potassium chloride, KCl, which statement is correct? It conducts electricity when solid because its ions are free to move. No, not correct. Because it conducts electricity in the molten or aqueous form only. In solid form, it cannot conduct electricity because the ions are tightly packed. Ions are regularly, tightly arranged. They are not able to move freely. Not able to move freely in the solid form. So that is why they cannot conduct. The ionic compounds. Potassium chloride is an ionic compound. So the ionic compounds cannot conduct in the solid form. This is wrong. It has high melting point because it has strong intermolecular forces. It has high melting point. Yes, it does have high melting point, but not because it has strong intermolecular forces. It has strong electrostatic forces. This is also wrong. It has strong electrostatic forces. Electrostatic forces. Then its structure is a giant lattice of alternating positive and negative ions, correct? It is soluble in water, correct? Most of the ionic compounds are soluble in water. So option D is correct, 3 and 4. How many electrons are shared in one molecule of nitrogen and in one molecule of ethene? One molecule of nitrogen means N2. One molecule of ethene is C double bond is C2H4. C2H4. This is ethene. And as for the nitrogen, nitrogen has a double bond structure like this. Sorry, triple bond. So one bond is equal to 2 shared electrons. One bond is equal to 2 shared electrons. So you can see that nitrogen has 3 bonds. So it means there will be 6 electrons, 6 shared electrons, because one bond means 2 shared electrons. So 3 bonds will mean 6 shared electrons. As for the ethene molecule, there are 1, 2, 3, 4, 5, 6. There are 6 bonds. 1, 2, 3, 4, 5, 6. There are 6 bonds. 6 bonds means total 12 shared electrons in ethene molecule. So the answer is C. Question number 9. What is the total number of electrons in one molecule of ammonia? One molecule of ammonia, total number of electrons. Now, for the total number of electrons, it means shared electrons, also the unshared electrons. Shared and unshared, both. Inner shell electrons, outer shell electrons, all of them. Total electrons. So for nitrogen, N, and nitrogen's atomic number is 7, so its configuration is 2 and 5. And we have 3 hydrogen here, 3 hydrogen atoms. and each is having one electron, right? So you can see here that 1, 2, nitrogen has total 7, 3 hydrogens, 3 hydrogen atoms, 7, 8, 9, and 10. So total we have, when we add them together, it comes out to be 10. So there are total 10 electrons in the molecule of ammonia. So the answer is C. Next question number 10. When heated, copper oxide reacts with ammonia. 8.5 gram of ammonia, this is the equation. 8.5 grams of ammonia reacts with an excess of copper oxide to produce 26.4 grams of copper. What is the percentage yield of copper in this reaction? Now, we have to find the percentage yield of copper. Percentage yield has the formula. Percentage yield is equal to actual yield divided by predicted yield multiplied by 100. So this is the formula. The yield which is given to us in the question is our actual yield. We have to find out the yield of copper. And 1 mass of copper is given in the question. This will be our actual yield, which is also experimental yield. Okay, so in the numerator, we will put 26.4 grams of copper. Now, to find out the predicted yield of copper, we will do the ratio, we will take the ratio between ammonia and copper. Here, the ammonia, we have 2 molecules of ammonia and we have 3 atoms of copper. So 2 ammonia, we will calculate for ammonia, NH3, ammonia mass, nitrogen is 14 plus hydrogen 1 multiplied by 3. Okay, so this is ammonia, 2 into 17. We'll multiply 2 with 17. It comes out to be 34. So ammonia is 34 grams in the equation. As for the copper, we will multiply the atomic mass of copper with 3 because here we have 3 moles of copper. Okay, so atomic mass of copper is 63.5. Okay, this is the atomic mass of copper, 63.5. So what we'll do, 63.5 multiplied by 3, it gives us 190.5 grams. So for the copper, 3 moles of copper, in the equation, the mass is 190.5. Now we'll take the ratio between ammonia and copper. Ammonia, ratio, copper. Okay, now from the equation, it's clear that 34 grams of ammonia are giving 190.5 grams of copper. Then 8.5 grams of copper will give, of ammonia will give how much copper? We'll multiply it. 8.5 multiplied by 190 divide by 34. It gives us 47.5 grams. So the actual yield is given in the question, which is 26.4 grams. We have taken out the predicted yield by the ratio, which is 47.5 multiplied by 100. It will give us the percentage yield of copper? It's 55. 55%. So the answer is C.